right, this is the rocket simulation part of the water rocket challenge. The simulation directions below, there are three tables. On the first simulation, you are changing the mass. The second simulation, you are changing the thrust. And the third simulation, you are changing the thrust time. Change the setting to massive chart. The drag and the mass change will always be on. Then graph the results and answer the questions. So it says the drag and the mass change will be on, so you have to check those to make sure that they're on. All right, so then what it says is that first one, what you're going to be doing is you're changing the mass. So you're going to start out at 3,000 kilograms. Now, okay, so if you can't quite get the number on there, you can use the up and down arrows, and it goes up and down by 10. Now, the thrust will always be at 100,000. There we go, all the way up to 100,000, and I can use the arrows to go up and down by 100. And then the thrust time is going to be at 40. Then what you do is you hit launch. And the rocket is going to launch. There we go. All right. And the rocket will continue to go up. And then eventually you can look at the stats over here on the side. And eventually it will come to stop. And it'll tell you, there you go. So it'll tell you what the height that it reached. In this one case, it reached 55 kilometers. So I'm going to restart it. Okay, so then you're going to do that. You're going to change it to 6,000, then 9,000, then 12,000. All right, so moving on to that next part. So the next part says start the thrust at 75,000. There we go. So I'm going to change this to 75,000. Oops, that was close. There we go. I'll just go down to 75,000. Use the arrows. The mass will stay at 6,000 kilograms, so we're going to keep this at 6,000 kilograms. There we go. There we go. And the time will stay at 40 seconds. So then you're going to hit start, and it's going to launch. So this is going to tell us how high it's going to go during these stats. Now, in this simulation, what we're going to do is we're going to change the thrust. So it reached 4 kilometers, and then you're going to increase it by 25,000 all the way up to 150,000. So we're going to see how thrust affects how high that rocket goes. Now, that last one says, well, you're going to start the thrust time at 40 seconds. So now we're changing that thrust time. Then it says the thrust will stay at 100,000. Go. Let's put it at 100,000, 7, 8, 9, and 100,000. And the mass stays at 6,000 kilograms. Well, then you're going to launch these, and what we're going to do is we are going to increase that thrust time. So how long that thrust is applied to the rocket. You can see here it reached 11 kilometers. Good. All right, so you're going to just increase the thrust time by 20 seconds, or sorry, 40 seconds, all the way up to the last one where you do the most time, which is 140 seconds. Then that you should be provided charts for that if you plug them into a Google Sheets. All right, the conclusion. Look at the thrust first height graph. If there was a challenge to make a 6,000 kilogram rocket with a thrust time of 40 seconds go to a height of 25 kilometers, how would you use that graph to determine the thrust? What thrust would likely make that rocket go to a height of 25 kilometers? Simulate this situation and describe its accuracy. So now you should have that chart, and you should be able to look at that and say, well, if I want this rocket to go to a height of 25 kilometers, what thrust would I have to apply? All right, question 5 is, how can this technique demonstrated in the simulation be used to accurately launch a water rocket to a specific height? And question number 6 is, thinking in terms of a water rocket, what would affect the mass of the rocket? What would affect the thrust of the rocket? And what would affect the thrust time of the rocket? Now, which of those 3 variables would be easiest to manipulate without affecting the other variables? Explain your answer. So once again, this is the rocket simulation part of the Water Rocket Challenge.